order the decimals. Now be very careful. Sometimes the problem will ask you to order it least to greatest, and sometimes it asks you to order it greatest to least. I'm going to say least to greatest. Now when you're ordering these, it's a little bit easier than the fractions, but you want to look at your decimal places because that's what's important. So when you look at them, you have a 0.09. Let's just look at, we have 0 and 0. Okay, so they all have a 0 in the tenths position. Okay, so then we want to branch out to the hundredths position. Okay, so this hundred has a 9, and this one has a 1, and this one has a 1, and this one has a 9. Okay, so if I'm going least, it's going to be the 2 1s. And this one is a 1 1. So that's going to be less than the 1 9. Okay? And so I started by just comparing the columns. So we had units, which were all zeros. We had tenths, which were all zeros. And so then we looked at hundredths. So now we'll look at the nines. So I have a 9 1 and a 9 9. So 9 1 comes before 9 9. And that's how it would look from least to greatest. Alright, lastly, they have scientific notation, and this is super small and I know you can't read it, but it is exactly the word for word part that you're going to see in the Math Lab assignment. Now, what they tell you to do in that first part is they say, hey, we're writing this in scientific notation, and scientific notation is a form that puts things in powers of 10. But what you have to do first is you have to put the decimal point behind the first non-zero digit. In other words, for this first one, I think I skipped over too far. I want to start with this one. If I put this, looking at this one, if I put it behind the first non-zero digit, I would put it right there. So my number is going to be 3.5779. In scientific notation, you want to pull it behind the first digit. So in this big number at the bottom, I'm going to put it right there. So it's going to be 4.369. You don't have to put the rest of the zeros? Nope, you do not. Now, remember how when we multiplied and divided by 10, we moved the decimal left and right? Well, that's what you're doing here as well. In this top pink one, I need to see how many times I moved the decimal. And so the decimal originally started here at the yellow point. And I moved it 1, 2, 3, 4 times. So this would be 10 to the 4th. And that's how that one would look. And that's what they're asking you to do. They're asking you to find that exponent. Okay, so let's look at this next one. Remember this huge number here that's 4,369,000. My decimal started here, so let's move it over to the pink. I moved it 1, 2, 3, 4, 5, 6 times. And it's 4.369 times 10 to the 6th. For some reason I'm having trouble with the pen. There we go. 10 to the 6th, and that's what it would look like. Now, if your numbers start out and they're above 1, meaning they're not a small decimal number, your exponent's going to be positive. So 35,000 was a big number, positive exponent. 4,369,000, that's a big number, positive exponent. Okay, but when you start talking about these that are little bitty decimal numbers, they're going to have negative exponents. Now, you're going to work it exactly the same way that you did the first one. So see, my first digit 7, my first non-zero digit 7. So this is going to be 7.027 times something. And looking at this one, my first non-zero digit's 2. So it's going to be 2.030048. Now then, all you're going to do after that is count the number of places you moved it. Right now, my decimal's right here. So I'm going to move it 1, 2, 3 places. But remember, it was a really small number. So since it was a really small number, that means it has a negative exponent. Okay, my decimal started here. I'm going to move it 1, 2, 3, 4, 5, 6 places. So it's going to be a 10 to the 6th, but remember it's a very small number, so that's going to be a negative exponent. And that's how it would look. Whew, I think we're finished.